Since the in the heating mode, the outdoor coil is the evaporator. Well, you got to have a metering device on the evaporator. The indoor coil is the condenser. You don't need the metering device. So typically, the metering devices in the heat pumps are designed that they either have a bypass or they have a biflow, or somehow they meter in one direction and allow refrigerant to flow in the other direction. They can do that by means of an accurator. It's a device that allows refrigerant to flow freely in one direction and it meters in the other direction. A lot of the units that have the thermal expansion valves on the heat pumps, the thermal expansion valve meters in one direction and allows refrigerant to flow freely in the other direction. If you have a heat pump outdoor unit, outdoor coil, and that thermal expansion device goes bad on that outdoor coil, you can't replace it with just any thermal expansion valve. You have to have a heat pump thermal expansion valve that has the internal bypass, made specifically for a heat pump. So on a heat pump, you don't say condenser and evaporator. You say outdoor unit, outdoor coil, and indoor coil, because they switch positions. Any other questions?
The defrost cycle, does it switch direction again, the defrost?
Right. The defrost cycle, which a heat pump has to have a means of defrost. Now, the older units had some electromechanical devices that had a mechanical timer similar to a refrigerator that would call for defrost, and you had a defrost thermostat that, if that defrost thermostat, which is on the outdoor coil, it's a temperature sensitive switch, and if the coil was frozen or below freezing, that switch would be closed. As a general rule, two conditions have to be met for a heat pump to go into the defrost cycle. When it's in the heating mode, the outdoor coil is frosted up. You got a defrost timer that calls for defrost every 30, 60, or 90 minutes. You can set them to call for defrost every 30 minutes, every 60 minutes, or every 90 minutes, depending on the geographical location. If you're in an area where you have a lot of moisture, you might want to set it to call for defrost every 30 minutes. If you're in an area that's moisture is not, or the humidity in the air is not too bad in the wintertime, you can set it to call for defrost every 60 minutes. It just depends. I'm thinking that they come from the factory, usually set to 90 minutes as a general rule. And if you want to set it, to something different, you have that option. But two conditions have to be met for a heat pump to go into defrost. Number one, the defrost timer has to call for defrost. Number two, the defrost thermostat has to be closed. If both those conditions are met, there's a defrost control that puts the unit into cooling. Let's say that your reversing valve solenoid coil is energized in the cooling mode. When it goes into defrost, it would energize this coil, switch the unit in cooling, which means your outdoor coil now was frosted up because it was the evaporator. Well, now it's a condenser. You got the hot refrigerant gas going to the outdoor coil, and it begins to melt the frost off the coil. You've got a couple of things that also occurs when a heat pump goes into defrost. The unit is put into cooling. The outdoor fan is de-energized through a normally closed set of contacts on your defrost control board. So you shut the fan off on the outdoor unit, and that speeds up the defrost cycle. It allows the frost to melt on the outdoor coil quicker. Also, your defrost control sends a 24-volt circuit to the inside unit to your heat strips, energizes your heat strips to temper the cooler air, because you've got the unit set on heating. Your thermostat set to heat, and it's in the heating mode. When it goes into defrost, it automatically goes into cooling mode, so it energizes those heat strips to temper that cool air. And then, once the defrost cycle is terminated, it goes back into the heating mode. Reversing valve solenoid coil is de-energized, and the outdoor coil is now the evaporator again, and the indoor coil is the condenser. And of course, your heat strips are de-energized unless it's calling for second stage heat, and your outdoor fan is energized, and it's moving air again across the outdoor coil. So knowing the operational sequence of the heat pump is, will help you in troubleshooting and diagnosing problems with a heat pump. But having a general understanding of heat pumps. I might mention something else. If you have a water source heat pump, you've got to have a water pump. That's another device or component that can go bad. The water pump stops pumping water through your coil. Guess what? Your water temperature is either going to overheat or it's going to get too cold.
Just like a fan stopping.
Like a fan, that's a good scenario. Just like a fan that quits moving air across that coil. And typically on your water source heat pumps where you have a water coil and an air coil, as a general rule, in the air conditioning mode, the indoor coil is the evaporator, and which is the air coil is the evaporator in the cooling mode, and the water coil is the condenser in the cooling mode. And in the heating mode, the air coil becomes the condenser, which is on the inside of the structure, and the water coil becomes the evaporator, and the refrigerant actually absorbs heat from the water. So if you got a water source heat pump with an air coil and a water coil, in the cooling mode, indoor coil, the air coil is your evaporator, the condenser is your water coil. In the heating mode, the indoor coil is the condenser, and the outdoor coil or the water coil is your evaporator. And again, having an understanding of how the basic air conditioner works, the basic vapor compression refrigeration cycle, you can understand how a heat pump works, because it's just an air conditioner in reverse. And what makes the difference? The reversing valve. You guys got any more questions? Anything you want to talk about?
Yes. How would you decide if you went to a homeowner and he wants to sit down and talk with you about what type of units should he put in? I said it already sheetrock is an old house. Would a package unit be more practical for him or that particular person, or depending on how the house built?
Well, as a general rule, when I worked in the field, Johnny, if you take an old house that's never had central heating and air conditioning, a package unit might be a prime, a really good installation or a good recommendation to the homeowner, because it's never had any duct work. You don't have an existing system, so a package unit would work well in that instance. I've seen situations where you got an older home, it does have central heating and air conditioning, your duct work is really old, it's under a crawl space, you got a really low crawl space. It's going to be really labor intensive and take a lot of effort to change that out. You might be able to offer the homeowner a lower price by installing a package unit, and it's a little bit more convenient. In terms of when a package unit is better than a split system, it just depends. A package unit is bigger physically. You got this really, you're going to have, it's going to be 2 or 3 times the size of just an outdoor unit or condensing unit. Or if you got a heat pump, your outdoor unit on a split system. Package unit's going to be bigger. When would you recommend a package unit over a split system? It just depends on the application. It depends on the type of structure. A heat pump is usually, a package unit is usually not quite as labor intensive to install as a split system, as a general rule. Although they cost more initially. The split system typically is a little bit more labor intensive, but when I worked in the field as a service tech, the companies I worked for usually recommended a package unit in an older home that's never had central heating and air conditioning. But again, it can vary. It just depends. Yes, sir.
So the mini split would be a good alternative in that situation, because you don't have to run ductwork.
Right. And again, and it just depends on a lot of light commercial applications. You see these units up on the roof. They're package units. They've got the indoor coil and the outdoor coil, both your indoor and outdoor fans. If it's air source to air, or if it's a gas furnace and regular air conditioners type system, you've got the unit in one package up on the roof. So it just depends. But it doesn't take you long to just look at a unit and determine whether it's a split system or package unit. Package unit is going to be bigger, and you got your, your duct connections attached to it, and of course your wiring. Split system, you're going to have your refrigerant lines and your wiring that connects the two components together. Any other questions? Samuel, can you think of anything?
You covered it pretty good.
Okay. All right, well, if you think of anything, let us know. That's what we're here for.